Hello everyone, welcome to my next tutorial. In this tutorial, we are going to discuss about electrode structure of organic light emitting device. So at here we will be discuss low reflectivity black electrode and high reflectivity metal electrode. How we can design these electrode structures. So before start of my tutorial, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. I have already given information about Impulse Technology my previous video. Who has not seen it my previous video, please check out the playlist. At here, firstly we will be focused in the small presentation and then I will be perform our tutorial. At here we are going to simulate electrode structure for OLED. Firstly, low reflectivity black electrodes. So it is a OLED. Low reflectivity or black rear electrode shall reduce the overall reflectivity to ambient light. That means organic light emitting devices are attractive for display application or to their self-emitting natures. A high contrast display however is characterized by low reflectivity for ambient light. A high contrast display made by LCD. This is achieved by polarizing layer that prevent the reflected ambient light to escape the display. So to illustrate the optical design of such type of electrode, we consider a simulation examples using aluminum, silicon dioxide and nickel. At multi-layer is presented here. We will be also discuss about high reflectivity metal electrodes. A high reflective electrode that also has reasonable electrical properties. So at the same layer structures, aluminum, silicon dioxides and nickel, we will be discuss same high reflectivity metal electrode. So I am going to perform a tutorial in the Setfos tools. Click at right side and run as a illustrator. About the Setfos, in my previous video, I have already explained about the Setfos and their GUI, how we can create our layer structures and how we can use our modules in the Setfos. So who has not seen it, please check out the playlist so you can get a lot of the information about the Setfos. It is a Setfos tools and it is examples and that is a module. For the create of the new simulation file, click at here. So firstly we will be provide each of the layer name. Here nickel, you can add more layer through the plus I symbols. I am considering here nickel, silicon dioxide and aluminum. It is a glass. Top and bottom layer are semi-infinite medium. So thickness are irrelevant at here. You can give at here 0. For the nickel thickness, you should be provide at here 10 nm. For the silicon dioxide, it will be same 100 nm. For the aluminum, it will be 100 nm. It totally depends on you which thickness you want. You can see at here the layer structures. It will be changed according to the thickness. Click at here. Now we need to provide refractive index for the air. It will be same 1. For the nickel, we need to import at here refractive index file that support a .nk file format. At here nickel.nk file formats, so you can easily import at here. For silicon dioxide, we need to mention at here 1.455. For the aluminum, we need to import at here refractive index file aluminum.nk. You can correct at here grass. At here nickel and aluminum, these two materials are chosen for superior optical or electrical properties. So therefore, we need to import at here their refractive index.nk file. At here layer structures are completed, but we need to define passive optics setting. So at here you can shift wavelength or energy, but we are going to shift at here wavelength. You can change at here the ranges. .450 to 660. It's totally depend on you which ranges you want. I'm considering at here these two. Wavelength you can change at here 530, and incident angle it will be same 0 degree. Now resulting reflectance map as a function of nickel and silicon dioxide layer thickness. So we need to vary the thickness combinations. So for low reflectivity around thickness combination we can change at here. So we need to activate shift modes, and we need to parameter at here nickel thickness. You can choose like that, and ranges you can consider at here 1 to 18. Step you can choose at here 2 nm. Now you need to also shift silicon dioxides, which have already I told you. So similar, you can choose thickness, and you can shift these parameter from 1 to 18. You can step consider at here 1 nm. It is a script for the black anode dot parse file. At here layer structure are completed, passive optic settings are also completed, and shift settings this parameter you want we can consider at here, we have already considered. So now you need to define at here your simulation file name, low reflectivity black electrode, and simply click at here play button. You can see at here the passive optic properties, reflectance for 530 nm, reflected color SEIR, transmittance, transmitted color it is a black. At here the absorption for the expolarization, and absorption for the depolarization. If you click at here the play button, you can see at here the variation. Delta, PSI, reflectance, reflectance for the expolarizations, and reflectance for the depolarization. It is a stacked contribution, and it is a transmittance. If you change at here the for the silicon dioxide x-axis, so you can change, and for the nickel, so you can change at here, and simply click at here the play button, and you can see at here the variation. Resulting reflectance map as a function of nickel and silicon dioxide layer. So low reflectivity around the combination of 7 nm for the nickel and 100 nm for the silicon dioxide. At here for the silicon dioxide, so 100 nm it will be low reflectivity. It generally a black layer concepts. Now I am going to discuss about the high reflectivity metal electrode. Black layer concepts discussed above. One may be interesting facts using a high reflectivity electrode that also has reasonable electrical properties. At this example, we are consider at here nickel and aluminum for the superior optical or electrical properties. For the glass layer thickness, if you want to change at here, and for the nickel, you can change at here 8 nm. It is generally a ranges, so reflectivity is minimal around at here. If you consider for the 160, so a flat reflectivity characteristics about 90%. You can give at here new names, and otherwise you can simply click at here and changes at here high reflectivity metal electrode. So some of the changes you can see at here for the silicon dioxides and for the nickels. At here the passive optic properties, and at here the spectral properties. But transmitted color it will be same as black. So I hope you understand my tutorial, and now you can easily create the high reflectivity metal electrodes and low reflectivity black electrodes. Now I'm going to end at here my tutorial. If you have any query related to this, you can ask in comment box, and in the description box email are also given, so you can easily contact us. You can also book our demo through the impulsetechnology.in website. Who has not seen it my previous video, please check out the playlist. Thank you very much.